Alright, so I just finished up machining this Y-axis bearing block. Overall, it turned out really well. There were some modifications that I wanted to make to some of the cam operations. So let's go into Fusion 360 and we'll discuss some of the changes. So here we are in Fusion 360, and I'd like to go over some of the cam operations that we're going to be using on the Y-axis bearing block. Most of these operations are pretty straightforward, but I did find some things that I wanted to kind of point out. Now, I'm going to be doing this in two different setups. One, I'm going to be machining the backside. This is a 2-inch deep piece of stock here, so I want to machine this portion here with one operation, and then that way finish it up when I flip it over. So for the bottom side, I'm going to be using this top right hand corner as my 0 for my X, Y, and Z, and then when I flip it over, I'm going to be using the top left corner. It's the same edge. That way when I flip it over, everything should be in the same orientation. Now, the bottom side is pretty straightforward. It's just a couple of drilling operations. I'm center drilling all three locations. Then I'm going to come back with a 5/16 drill bit and bore all the way through. And then I'm going to come back with a 3/8 inch end mill and do a two-dimensional boring operation, and then just bore this out. And then we're going to flip it over and we're going to do the top side. Again, our origin point for our stock is the top left hand corner. We're going to do some drilling operations. Center drill. We're going to come back and drill for our bearing cover. This is a 3/32 drill bit because these are M3 threads. You have to take your time. You can't go too deep, as I found out, or you'll break a bit. Then we're going to come back and we're going to drill our two outside mounting locations. We're going to drill those all the way through. We're going to come back with a 1/4 inch end mill and we're going to do this relief. And then we're going to concentrate on our bearing pocket. And this is where I ran into some problems. On the original bearing block, the first time I did it, ramped all the way in to the bottom and then worked my way out, similar to the way I did it on the stepper motor mounts. However, this is about 1.3 inches deep, and that's a lot of material. The machine handled it just fine. The problem is trying to evacuate all these chips. As you can see, I just ramped all the way down to the bottom and then cleared this hole out. In the simulation, it looks pretty good. We're just ramping down, and then once we get to the bottom, we just start to make it bigger. But you can see the end mill is all the way down. This is 1.5 inches flute length. On this is 1.5 inches, and that's a lot of material. The problem was I couldn't evacuate all these chips out of here when I ran this part. I had to stop it in the middle, clean the chips out, and run some more. It was just didn't work out really well. So what I thought I'd do is just maybe do 2 steps. So I came to my cam operation here and I changed the maximum roughing step down. Instead of going the full distance, I changed it to 0.75. And so with only 3/4 of an inch step down, I can make 2 passes. So I'll go down, ramp down 3/4 of an inch and then go out, and then go down another 3/4 and go out. Hopefully this will take care of evacuating these chips. We're going to see. Another option would be to just mill with the boring operation and use a step over and sort of take 40 thousandths each pass. Now this would definitely take care of the problems of the chips. However, it's not the most efficient way to machine this out, I don't think. You're only using the end of the end mill to cut, and preferably you'd like to use the side as much as possible. However, this will work, and again, this center section right here would be removed with a drilling operation. So I may have to use that if this doesn't work out. This is all trial and error. We're then going to come back, and I left 50 thousandths on this operation, and then we're going to come back and take it down to 4 thousandths undersized, and then we'll come back with one more operation and clean it up. That way, if we have, because this is such a long end mill, if we have any kind of tool deflection, that should clean that out. Next, we're going to just do the outside and then finish it up with one pass for the outside. So now let's go out to the mill and we'll machine this out. Alright, so I've got the stock flipped over and I've re-indicated on this corner here, and so we're going to run the front side. Looks like we've broke a bit. Alright. Well, let's get that changed out. Alright, we're going to change it out to a 5/16 drill bit. Okay, I've got my drill bit changed out to 5/16, but I'm also going to slow it down, the gearbox, and put it in high 1. ignition switched out. We're going to come back and we're going to do the recess for the bolts. Alright, we're going to change out the bit. And now we're going to start working on our bearing pocket. Alright, I'm going to switch it out to a shorter 3/8 inch end mill, and we're going to come back and we're going to do the recess around the sides. Trying to keep the chips evacuated is probably the most challenging thing. It seems like the Precision Matthews was able to handle. Really satisfied with the way the Precision Matthews performed. There's still a little bit of tweaking. The bearing pocket still needs a little bit of tweaking as far as that first roughing pass. It was still filling up with a lot of chips, and so I'm going to have to try to come up with a different cam operation. Maybe bore a hole all the way through first and then come back. I don't really know. With such a deep cavity, it's probably going to be pretty difficult to flush all those chips out. I may have to go with a double nozzle situation. I think I'm going to do that anyways. Overall, I'm pretty satisfied with the finish that I got. Taking a full depth of cut, I mean, that is, I don't know if you can see it on the camera, but that is really smooth. No chatter. I mean, it is nice. So let me get this cleaned up. We'll get it out and we'll wrap it up. Alright. Really happy and satisfied with the overall finish that I got from the Precision Matthews. The only thing that I need to change is this initial roughing of the bearing pocket, because it just fills up with chips. It was even worse when I did the original one, so there's definitely more tweaking that you have to do. That's one thing about CNC machining that I found over the last few years, is you never get it right the first, second, third. Sometimes it takes 5 or 6 runs to actually tweak the G-code and get it running exactly the way you want it. The bearings are just a nice slip fit. I don't want them pressed in. I don't want them too loose. They fit in there really nice. The spacer goes in, and then the last bearing. I'm going to have to trim the spacer down a little bit. Of course, then the cap goes on, and this one will get trimmed. But that is nice. Really happy so far. I got to come back and tap these holes. I did have a drill bit break on this hole, so I'm going to have to either try to get that out, re-drill it, or just move the hole to a different position, I guess. It's not really a big deal, but it doesn't look very good. So that wraps up this video. Of course, this will go together like so. Very nice tight fit. Fits in there good. Keeps everything centered. So that wraps up this video. Thanks for watching. Stay tuned to the next video. We're going to start working on the Z-axis bearing block. Please subscribe to the YouTube channel. Stop by and visit the website. And most importantly, be safe.